Liat Moss, and it's so nice to be speaking at Techno Day for International Women's Day. Today I'm going to talk about the STEAM education tools I used to teach myself how to code. A little bit about myself. I'm currently a software engineer at Prosper in Sydney, Australia, working mainly on the back end in C#. Before I was a software developer, I worked in education for a number of years in London, first as a classroom teacher, and then as an educational technology consultant, working with schools and organizations to help teach coding and computing to primary and secondary school students and teachers. When I first started teaching, there were very few resources available for teachers to explain how to teach coding and computing concepts to children. A new computing curriculum had just been released, and there was little to no guidance on how to actually go about teaching it. The school I was at asked me to work with the teachers and students to help write a curriculum that the other teachers would be able to follow on their own. I was brand new to coding, never coded anything before in my life, and knew I'd need to find a way to teach myself before I'd be able to teach my students. So this talk is called Learning to Code with STEAM Education Tools. So what is STEAM? STEAM stands for Science, Technology, Engineering, Art, and Mathematics. The term was created as an interdisciplinary approach to teaching and learning. When teaching using STEAM, students are encouraged to work together to solve problems across multiple disciplines. It's not just about writing code. It's using code to retell a story that the students are currently reading, or designing a robot to have certain features and understanding how it all fits together before starting to build, create, and code it. Everything I'm going to go through today, from websites to write code and the hardware that goes with it, are all tools that can be used in this approach to learning. And I think that's what makes them so great. No matter what your skill level, there are ways to have fun and engage with them. And this is really what got me so interested in coding and computing, and why I decided to pursue it as a career. I came across all of these programs as an absolute beginner, so that's how I'm going to go through it today with all of you, to show you how much fun learning to code can be from the very start of the journey. The first website I was introduced to is Scratch. Scratch is a brilliant, very open-ended program designed to teach coding in a really fun way. The coding blocks are different colors depending on what you're looking to use, and they snap together to show a step-by-step synchronous guide as to what the program is going to do and run. The programs in Scratch can be as simple or as complex as you'd like them to be, and they can introduce a range of computing concepts, such as variables. This is a really simple program I have on the screen now that will make the Scratch cat say hello, and then do a little dance back and forth on the screen 4 times. With only a small number of blocks, we're able to write a really basic algorithm. So let's have a look at what this program does. So the cat says hello and moves 1, 2, 3, and 4 times across the screen. Now, while this program does what we expect it to do, it's really long and very repetitive. Luckily, in Scratch, there are blocks that we can use to simplify this code. It's here that we can introduce loop counters as a way to refactor our code to make it better. A loop counter will repeat a selected section of our code a specified number of times. So here I've got my repeat block that I'm moving into place. I'm finding the blocks that can be used that are repeated multiple times, and I'm moving that into the repeat block. When the program is started, the cat says hello, and again moves 1, 2, 3, and 4 times across the screen. And look at that. While refactoring our code, we've learned a new coding concept. Scratch has changed a lot since I first started learning to code. You're now able to program a number of other devices using Scratch's extension blocks. Connect a Makey, a microbit, or one of the Lego robotics kits, and you'll be able to write code directly in Scratch that can be used to program these devices, either by using a USB stick for the Makey, or via Bluetooth for the microbit and the Lego. One of the things that I love about STEAM education is that learning to code isn't just about sitting at a desk and writing line after line of code. This is, of course, part of it, but there is just so much more. And one of the best tools I found for this interdisciplinary way of learning to code is the microbit. This small piece of hardware is incredibly versatile, and the possibilities are pretty much limitless. The best thing about the small microcontroller is that you don't actually need to have one with you to code on it. The emulator on the MakeCode website, which you see on the screen, allows you to write your algorithm and test it before putting it on the actual microbit. So you're able to debug your code without needing that physical device next to you. The blocks used to code the microbit are also similar to Scratch, so it's an easy progression from one to the next. So here we have a simple program using the loop counter we learned about in Scratch. When the program is started, the heart beats 10 times on the screen and then turns off. Now, although this is a great first program, it is a little boring. The microbit has buttons and inputs we can use to make this code a lot more interesting. So along with the 2 buttons and the 5x5 display of LEDs and the edge board you see at the bottom, the microbit has a whole range of features that aren't visible from the front. There is a microphone and an onboard speaker, accelerometer, light and temperature sensors, and Bluetooth, so that multiple microbits are able to talk to each other. So here's an example of a really simple program using some of these features we've just mentioned. So when the program starts, the heart beats on the screen this time 5 times. We're using the accelerometer to shake the microbit. And this time, instead of displaying an image, we're scrolling the word hello across the screen. And when we push button A, it shows us the duck, and then it plays us a song. There are many fantastic features of the microbit, and the fact that it's wearable gives us a whole new range of activities we can do with it. The microbit is easy to connect to clothes, either with Velcro or sewing it directly onto different outfits using these 2 holes next to the buttons. These are some examples of outfits I've made using the microbit. This first one is a skirt with an LED strip that contains 124 LEDs. They rotate around the skirt as soon as the program starts, and they stay rotating for 10 seconds. Because of the large amount of LEDs needed for this project, I had to use a second battery pack to increase the voltage so that all the lights were able to work at the same time. Because of this, while the skirt worked really well, it was quite large to move around. So I wanted to make something a little smaller, but using similar code. I decided to make a hat which I could take on and off and was easy to travel with. This one has only 5 LEDs, which are attached to a cardboard hat with Velcro, and that then sat on top of a headband. This was a little tricky because instead of using one long strip of LEDs like I used for the skirt, I was using 5 smaller LEDs that were all individual and needed to be connected to each other, to the microbit and the hat in some way. I figured that the hat, being so small, was going to look a little strange anyway, so having wires sticking out probably wasn't going to be too much of an issue. I found some fun colored wires, and after a bit of experimenting, I managed to get them connected to the microbit with the help of some conductive tape. I then stuck all of that onto the hat with some extra Velcro and tucked the battery pack into the hat through that small hole you see at the top. And this is the final result of me wearing that hat. I'll go through a quick rundown of the code for the hat, as it actually has a few different settings. First, we need to set up the microbit in that start block so that the LEDs are connected in the right way. Here I'm connecting my LEDs to pin 0, as it says in that red and blue block of code. This pin 0 will connect to the data input on my LED. The G&D or ground will connect to the ground point on the LED, and the 3 volts will connect to the voltage pin. So on the screen, you can see an example of what the LED I was using looked like and a table I put together to help with building the circuit. It's really important to make sure that whatever pin is mentioned in the code, that's the pin that is being used in the circuit. The first step to debugging this process is to make sure that the circuit is wired correctly to match the code. If the code is using P1 or P2, then the wiring should match P1 or P2. And here we have the actual code that was written for the buttons. The code is essentially the same, but they are rotating different colors for the LEDs. Both are using the loop counter, which we're now familiar with, and they're showing each color for 200 milliseconds before changing to the next. The last 2 blocks after the loop are clear and show. This clears the LED strip and turns the lights off. So we clear the strip and then show that it has been cleared. So this is what the program looks like for each button when it has been run. So this is for button A. And then we've got different colors for button B. So we've now completed our first full STEAM activity. We've written the code for the microbit using loops, and we have debugged any issues with our code using the emulator on the screen. We've learned about the inputs on the microbit, mainly the buttons and the accelerometer. And although we didn't discuss it directly, we are using variables here as well to set the LEDs. We've also looked into some science concepts, mainly around LEDs, so light emitting diodes, and making circuits, making sure that one part of the circuit is grounded, one part connected to power or voltage, and the third to the input on the microbit. We've also created and designed the hat and the way that the LEDs and microbits are all connected. I want to touch on a few other great STEAM tools for learning to code. Sticking with the physical computing, this is the Makey Makey. It's essentially a keyboard hack, as I would tell my students when I was teaching. You plug this in and it replaces certain keys on your keyboard with anything that conducts electricity. It never gets old telling people they can play computer games using bananas. Makey Makey is great, especially because it is so compatible with Scratch. It's a fun way to investigate making your own game controllers and looking at ways to incorporate real-world items into your programs. With one group of students on a holiday camp, we dissected the Scratch cat for a game of Operation using chopsticks coated in tinfoil and created interactive robots that were programmed in Scratch but used the Makey Makey to run. And the last piece of physical computing I want to talk about is the Raspberry Pi. There are many variations of the Raspberry Pi board, but I like working with this one, which is the Raspberry Pi Zero. This is a small computer that runs its own operating system, and it's quite small, so it's easy to carry around. Using a breadboard, as seen in the photos, you can attach LEDs, buzzers, cameras, and a range of other inputs which can be coded on the Raspberry Pi using Scratch or a text-based coding language like Python. So I like using the Raspberry Pi because it's wearable. So for the size of the device, it's really easy to attach to a badge or a necklace and can be powered using a portable phone charger with a micro USB cable. So this video is using the Raspberry Pi Zero and the unicorn hat from Pimaroni and has a random color program loaded into it, and it's actually one that I'm wearing today as well. The Raspberry Pi website has some great tutorials and activities for all ages and abilities. If you're interested in learning to code with the Raspberry Pi, I would highly recommend having a look at the resources available. I used a number of their online tutorials when I was learning to code, and they're a great introduction to physical computing. There are also some websites I would recommend looking at if you're starting your coding journey, or maybe you're looking to engage with some younger children who are learning to code. The first one I'd start with is code.org, especially if you're brand new to coding. Their programming starts off quite simple, and they have videos with fantastic explanations for learning coding concepts such as loops, if statements, and functions, as well as many more. They use kid-friendly characters from Angry Birds, Frozen, Minecraft, and Star Wars, just to name a few. Another great programming website is Code for Life. This is a UK-based site built by Ocado. The programmer attempts to drive the truck and make their deliveries in a game. And I do say attempt because my students like the sound effects of this so much that they kept crashing the car. I would recommend this website for after looking at code.org, or if you're playing with children, this is for slightly older children than code.org. The levels move at a much faster pace, and towards the end, once all the concepts have been covered, there is an introduction to Python and text-based coding. The levels start out like this, using blocks to demonstrate what the code looks like, and then moves to typed code once the language becomes familiar. There are also some wonderful books out there for learning to code. These are a few that I have picked up during my coding journey. Microbit in Wonderland has some really nice activities for coding with the microbit. It's a great way to cross literature with coding, and there are some wonderful craft activities in there too. The hat that I talked about earlier started as an activity from this book. I'd also like to mention Python basics. Using this book, I wrote my first text-based code. The explanations are simple and easy to understand, and the activities get more complex the further into the book you go. I use this as my starting point before writing Python code on the Raspberry Pi. While I was doing my coding bootcamp, the one that helped me transition into software development, we were told this on a daily basis, and I still remind myself of this every day. Learning to code can have its challenges. You are learning to think in a new way, but it's all new information. And while it might seem hard now, it won't be the more you keep working on it. So it's not hard, it's new. Thank you very much for listening to me today, and please reach out with any questions you may have.